Jed, I guess everyone else is slacking. I don't know. I just started a little bit early, to be fair. That thing went for like a minute and a half or something without being claimed. Okay. So I think we're going to continue trying to speedrun learning some mechanics, at least to start off until we get a question. And yesterday I was spending a good amount of time just going through, why am I scrolling this the old-fashioned way? Going through this kinematics in 1D, and I was struggling with it. It feels like I was struggling with it a sad amount. Like we just have this, like this is the fundamental idea is just take the derivative position to get velocity, take the derivative again to get acceleration, and then you can integrate the other way. That's fundamentally all there is like to this chapter, but they're asking some tough questions. I did all the multiple choice, and then in the problems I did 1 through 3. So let's look at number 4. Okay, if you ride a bike up a hill at 10 miles per hour, then down the hill at 20 miles per hour, what is your average speed? This is a trick question. Isn't the average speed still 0? Because the displacement is 0? Wait, speed. No, yeah, I think, well, no. They're saying speed, not velocity. Wait, well, speed is the magnitude of velocity. Velocity, you can have positive or negative. Speed is always positive. Yeah, and so yeah, it needs to be a weighted average because we're only going 20 miles per hour for half as long. Which it might end up working out to be 15 for that reason. I don't work that out, but so like I think the trick the average velocity is displacement over change in time. That would be 0. But average speed, I think, is a different thing. The speed is the magnitude of velocity, which is the absolute value of v in 1D, the length. Yeah. So I think for A, it might just be 15. How do we, I guess we weight this by time? So like we go 10 miles an hour for some time t plus 20 miles an hour for half that time. And this is these units are distance, but that's okay because sure, I'm just saying it's okay. Is it 10? I'm getting 10. Wait, no, am I? Yes. Which, that kind of seems reasonable. Wait, biking downhill at 20 miles per hour, that's kind of scary on a bike. You got 13.3? By doing a random distance like 40? Okay, so if the distance is 40, it would take um 4 hours. Oh wait, the entire hill's 40, so 20. Okay, yeah, 40 up and 40 down. So it'll be 4 hours up at 10 miles per hour. And then the way back down is 2 hours at 20 miles per hour. Isn't that working out to be 20 again? Or 10? Because we do 10 times 4 plus 2 times 20 over, I guess we would do 6. Oh. Yeah, maybe in the denominator here, it's not 2, it's t plus t over 2, which is 3 over 2t. So what is that? 40 plus 40 is 80. Forty over 3. Yeah, that's 13 and a third. Huh. That's just a weird number. Does this calculation agree up here if I do it with this adjusted thing? This would be 20 over 3 over 2, which is 40 over 3. Okay, I guess our answer for A is 13.3. What's our answer for B? I haven't even read B. You go on a bike ride and ride for half the time at 10 miles per hour and half the time at 20 miles per hour. Is this not the same question? Wait, half the time? No, it is a different question. This average speed might be 15. Because the time periods are the same. So yeah, a 2-hour trip is a good idea because you would do 1 hour at 10 miles an hour and then an hour at 20 miles per hour, and then divided by 2 hours. I think 15 is reasonable for 2B or for 4B. Okay. I think we'll check the answer on this. Generalize it for K and NK miles per hour. I mean, I think it's gonna be the same idea. Wait, where am I? Okay. Wait. Okay. 2.4 down here. 13.3. And that one is 15. Okay. Nailed it. These are the multiple choices. Okay, 2.5, colliding trains. Two trains A and B travel in the same direction on the same set of tracks. A starts at rest at position D. B starts with velocity v naught at the origin. Accelerates with acceleration A. B decelerates with acceleration minus A. What is the maximum value of v naught in terms of d and A for which same direction, same set of tracks. Huh. Okay, so that's a train, trust me. Just a very boxy train. Okay, so A starts at, okay, so this is A. X equals, or X of 0 is D. V of 0 is 0. A is always A. Or A of T, I guess, is A. Bad notation, but who cares? For B, X of 0 is 0. V of 0 is V naught. A of T is minus A. D plus ND over NK. Yeah, it's something like that. Sereno. So B starts at the origin as well. And so the question is, does A get away from B fast enough? So maybe we want an X versus T plot where they barely collide like the hint says. So A starts high and keeps going up. Is that right? Yeah. No. No. This isn't linear. They both have constant accelerations. I should match the colors. A's position equation is going to be D plus 1/2 AT squared. B's is going to be V naught T minus a half at squared. And so A starts high and goes up like that. That doesn't make sense. You define the maximum V naught such that when VA equals VB, XA is greater than XB. That sounds like a JED, yeah. Oh, okay, so the reason I'm getting confused with B is how to actually graph this thing. It has a 0 here, and its other 0 is somewhere out here. So if they barely collide, it would look something like that. Like they only intersect once. And so I think what we're going to do is set these two things equal to each other and force the discriminant to be 0. Yeah, because what the V naught here is doing is it should be influencing the shape of this parabola in some way. It's not that clean. But I feel like the idea is we are interested in x of t equals x naught of t. So v naught t minus 1/2 at squared equals d plus 1/2 at squared. I should do xb and xa. I've been using this color coding thing just because it appeals to me. But you're right, it should be xa and xt. I'm just using the colors as a substitute for subscripts, I guess. Colors work for you. I mean, yeah, if you're colorblind, then just, you're not welcome here, I guess. That's what I'm trying to say. Yeah, okay, you're right. You can do the /me thing, I guess, but works for that's not really clean. So the quadratic formula for this thing is v naught plus or minus root b squared minus 4ac. A is a here, both confusingly and conveniently. If you're colorblind, yeah, exactly. Okay, and so these things, we're interested in when this discriminant is equal to 0. So v naught squared plus 4a v naught equals 0. Let's factor out the v naught. So v naught equals 0, I'd say that's trivial. Actually, does that even... If v naught is 0, what do we even get? I think it's a parabola that will be like that. So that's not what we want. That's an extraneous solution there. Or V naught is minus 4a. Does that sign make sense? Yeah, because the velocity should be opposing the acceleration. That's the only way this thing works. Oh, you're right. Yeah, it will be moving backwards. Yeah. The maximum value of V naught for which the trains do not collide. Yeah, okay. So this is where they collide exactly. Well, they can only collide once, but this is where the parabolas just barely touch each other, is the idea. They intersect once, and if this orange parabola were to get any bigger, they would intersect twice. So we want V naught to be strictly less than minus 4a. Let's go check the answer. Because it needs to... If the train is decelerating, like, it needs to have positive initial velocity. Well, that's the weird thing where the initial velocity of B needs to be negative. A is a positive number, but B has deceleration minus, or acceleration minus A. Actually, I see what you mean, Jed. Wouldn't V not be dependent? Oh, I messed up. 4AC. Throw all that out. You're right, it should absolutely be dependent on D. I just used the quadratic formula wrong. Yep. Well, that's still... Oh, no, this becomes a minus. Okay. That looks familiar. I wonder if there's a quicker way to do it than what I did. So we want V naught less than 2 root AD. This looks familiar because it matches this thing right here. Oh, there's an extra factor of root 2, I guess, but it's nearly the same thing. So they'll probably say a formula for how we could have. They'll probably say a way that we could have applied that in some way. Let's see what they say though. I don't know. Wait. What? The minus root? Oh no. Wait, what the hell? Oh, never mind. I think they're talking about like the root of this original thing. Yeah. Okay, so they actually don't give a solution using that formula. Interesting. You show that the location where the trains barely collide, the v naught equals root 2ad cases x equals 3d over 2. Just plug it into either formula. I guess you have to plug in for t as well, but that's not that bad. Yeah, I just read that too. Just casually reversing your jet. I really hope that the jet would make like the beep, beep, beep thing. And the a goes to zero limit, b moves at essentially constant speed v naught toward a. Wait, what's happening? As a goes to zero, b moves away with essentially constant speed v naught toward a, which is essentially at rest, initially a distance d away. So time is simply d over v naught. I'm expecting to apply Taylor series equation 2.16 to produce this t equals d over v naught result. A Taylor series of... What's up with this? What's equation 2.16? Wait, what? Where do we get the 16 equations from? 2.16. Oh, was it? Ah, okay. So wait, this is the a going to zero limit? Okay, yeah, we would get 0 over 0. Can't L'Hopitals? I want to try L'Hopitals on this too. So a is our variable in that. Okay, yeah, I want to look at this. The limit as a goes to 0 of v naught plus or minus root v naught squared minus 4 ad over 2a. This is 0 over 0, so I just want to see how it ends if you L'Hopitals. Chain rule. Well, we can just take the limit. What does this give us? The 4's cancel, which could plus or minus d over v naught. Was that what we wanted? D over v naught. Okay. What Taylor series would you want here? They probably Taylor series to expand the top. So like root 1 minus x or something like that. More in your other books, save me. Wait, do you give common Taylor series in this book, Warren? Ugh. Taylor series. Okay, root 1 plus x. So we'd have to do some massaging of the square root here. One minus 4ad over v squared. Oop. Oh my god. 4d over v squared a. Just make it clear what's the coefficient here. It gets square rooted on the way out of this. Oh, that is what you mean. Thank you. Wait, I need to see this. I need to see more terms. This, is it alternating or not? Is the one just like a singleton and like it's alternating after that one? How does it present it in this book? Same thing. Dang it. I don't get the pattern. Oops. With the signs. That looks like a winking face wearing eyeglasses with only one arm. I can kind of see that, like the 2 is the arm and the V is the wink. Okay, well actually we only care about probably the first 3 terms, so let's only care about the first 3 terms. The caret is the arm, the 2 is the ear. Oh, well that's like... Is that? Hey, Cook. How's it going? Oh, good. That's a good clip right there. So it's 1 plus... oh, V naught is on the outside. Wait. 1 plus x over 2, and this entire thing is x? The next term is minus x squared over 8. So I think that one's going to stay negative. Oh, I did forget the 2 on the bottom. We probably don't have to care about the 3rd term either, to be honest. Uh... 2dA over v naught. We want to redistribute. Okay, so the goal of this was to do this limit via Taylor series rather than L'Hopitals, because physicists, I guess, don't like L'Hopitals. V naught plus or minus V naught minus 2dA over V naught over 2a. Doesn't, wait. Well, that's not good. I can see we're going to get a d over v naught right there. Yeah, I guess we're going to take the minus. Yeah. So yeah, the two ways cancel. It becomes positive, so d over v naught. Okay. Same limit two ways. Although I like one way way more. Oh, it's I'm going through that book. So I've just been starting on chapter, or I'm not starting. I did like nearly all the problems yesterday off stream. They were surprisingly challenging. I was having trouble with them, but the one that we just did was number 5 there. Ariam Legend over on YouTube. In a card game, you are selecting 3 cards from a standard deck of 52 cards. How many different sets of 3 cards can you choose from the deck? In a card game, you're selecting 3 cards from a standard deck of 52 cards. How many different sets of 3 cards can you choose from the deck? I think that's 52. Choose 3. Ariam, do you know how to use like a? It can be written in different ways, but it can be written like 52 choose 3, or I think like they do like a big C and then like 52 choose 3 like that. And kind of like I think this is the definition of choose, which is like these get you how many ways there are to choose 3 things out of 52 total things. And so you can calculate that with a calculator or with the or with a formula involving factorials. So n choose r is equal to n factorial over r factorial, n minus r factorial. So then 52 choose 3. Oh, this is definitely a calculator problem. I would not do this by hand. Oh, this is, well, maybe. No, actually, no. It'll simplify. 49 factorial. And so the 49 can cancel with a lot of this 52 factorial, but we still have 52 times 51 times 50 remaining. 52 times 51 times 50 over 3 times 2. I would sleep. I mean, this isn't that bad to do by hand, but I'm just going to use a calculator. Choose 52, 3. So 22,100, Ariam Legend. Physics teacher's going to fucking hate me. I got the exact labor sign of 2 degrees in the exercise answer. It's too long to render properly. Oh no. Syntax error, you just love torturing your teachers. Joseph, I think I'm slowly getting better at writing proofs. Got 28.5 out of 30 in recent Poset. Nice! Proofs are hard. I could have done it in my head. I just am lazy. All right. Thank you for sorry about a little bit of a wait there, Ariam, but I hope that helps you. Okay, so let's look at number 6 here. 2 cars, A and B. Actually, let me just no, we'll read it here and then we'll put it in paint. 2 cars, A and B, start at the same position with the same speed v naught. Car A travels at constant speed. Car B decelerates at constant acceleration minus A. When B reaches a speed of 0, what is the ratio of distance traveled by A and B? Draw a reasonably accurate plot of x versus t for both cars, okay? Finding the answer for the ratio distance is a nice simple number independent of any of the given quantities. Really? Okay. Yeah. Syntax error. If your professor said to do a reasonably accurate plot, I feel like you would really take that and run. Number systems and sequences. Ooh, nice. Is this linear algebra? I assume you're not referring to the thing I'm looking at, Cook. Maybe what Syntax or Joseph are saying? All right. Time for the expert artist to draw two cars here. There's one car. No, your orange car. You can't change. And we're gonna have a green car. Perfect. Couldn't be better. Sub 0 is 0. V of 0. Well, V of t is V naught because A has constant speed. V of t is V naught minus AT. Wait. You're canceling the 2 with the 52. I was going to cancel the 2 with the 50. Oh, 3 goes into 51. I didn't realize that. Yeah, it does. I guess, yeah, keeping the 100 up there. That's... Without writing it, that's not easy. If you have... God damn it, Jed, you're right. If you have 3 consecutive numbers, you can also use a calculator, though. Okay. Um... So on an x and t plot. Okay, so A is just linear like that. B is quadratic like that. The instant when B reaches speed of 0, does the ratio distances traveled by A and B. So We don't have to worry about displacement versus distance here. These formulas are technically for displacement, but they're just moving in one direction here, so it's going to be the same thing as distance traveled. We first need to figure out, when does B have 0 velocity? The graph isn't quite right. What? B can never get ahead of A. Oh, yeah. Oh, okay, fine. You're right. Hey, Mean Machine Rex, how's it going? You're right, because B will start out with like basically the same slope, but then it's going to level off like that. Yeah. I mean, I was just trying to get the shapes right. I should have thought about the intersections, but I wasn't. So when t equals v naught over a is this point right here. Wait. Yes? I should check that. I mean, I should check that point against here, or that like time t. I think you look like a cute little Funko toy. I'll take it, Rex. Thank you. Wait. Shouldn't these things should agree? Then when B reaches a speed of 0. Oh, wait. No, it has. Okay, I'm just getting mixed up with my plots. Why is this so weird? Like, what I was going to do is just take this value of t, plug it in for each of these, and divide them. But I feel confused because but I isn't I see just like the zeros of this thing, they don't match. There's the 1/2 there. And I feel like this v naught over a is right here. I don't know. This feels weird. I guess it wouldn't be, no, it needs to, it's because like but I feel like they should match. Like once the velocity zeroes out, we don't keep moving after this point here. Like there should be some coincidence here, I thought. Hi, thank you for the kind words. I feel very stupid right now, but so when b reaches speed of 0, what is the ratio of distance traveled by a and b? Okay, let's just get the actual answer. I'm still confused about the interpretation. You would take points off for the x versus t graph. The slope. Oh my god. It's hard to draw accurately in paint. I agree. The slope should match though. Is it a waterfall wall at x equals 0 or a brick wall at x equals 0? What is physics? Ugh. At x equals 0. I don't know. Be whatever your heart desires. That's a squared, I promise. I want to see, when does the I want to see the plot of the velocity and the position for car B at the same time. So I'm not understanding something here. Like, my instinct says that the graph for B's velocity should be something like that, where the zeros coincide there. But that doesn't seem to actually happen when I plug numbers in. B goes out, reaches zero velocity at some positive distance, reverses to a negative velocity, then later returns. Oh, that's why it's only halfway. B reaches speed of 0. Okay. Okay, that makes sense, and thank you, Cook, because I didn't realize that, like, B has been going backwards for this entire section. That makes perfect sense. I just am not smart, I guess. Like, when I was doing the questions yesterday off stream, I lost all confidence in myself because I was struggling hard. This is better than I was going yesterday, and it's still not going well. The ratio of distances traveled by A and B. It's 2, right? Because it's 1 over 1/2. Wait, no, I'm flipping it, aren't I? X. I didn't even do that. XA isn't twice of B2, though. Yes, it is. That does make sense. Okay, we're good. We're saying... Oh, that's a terrible color. Oh my god. Right there. That's basically halfway, I guess, to the bottom. Thank you, Rex. Okay, 2. Mary explains why this is the case. That it doesn't depend on any of the given quantities. Okay, it doesn't depend on the given quantities, but it does depend on one having... I mean, doesn't it still depend on one having zero acceleration, the other one having constant acceleration? So... It shouldn't depend on V naught because they both start with the same... my result is 2. But... they also need to explain why it doesn't depend on V naught or A. So I think it shouldn't depend on V naught because they just both have the same initial velocity. For why it shouldn't depend on A, that's kind of curious. Think about the dimensions of the given quantities. Hey, Tyler. um... And they both have an impact on t for when v of bt equals 0. Right, but for whatever reason, when we take the ratio of the distances, they go away. But yeah, so we did the actual problem, Jet. I got 2. We're trying to explain why is it just 2 and not involving V naught or A. What kind of dimensional quantities can you form with only A and V naught? What dimension must your answer have? Well, if we're dividing them, then seconds. Which, I mean... we're just dividing 2 positions here. I think that's a little bit too simple. A ratio of distances is dimensionless. Isn't that... I thought there was going to be something deeper. Can you form a dimensionless quantity with A and V naught? Not without involving time. Right? Otherwise you're always gonna have like a spare unit of seconds or something. Okay, Kusama. The actual, like, final answer is right there, Jed. Possible form any dimensionless quantity with only A and V naught. Oh. Okay, I see what you're saying. So as soon as we read the question, we know it can't... We know that the ratio of distances should be dimensionless. And using only A naught, or using only A and V naught, there's no way to combine those to get a dimensionless quantity. Wow. Okay. $2.6. Just claims within reach. Okay. Okay, 2. That is a reasonably accurate plot. Because I have a physics paper tomorrow. Any tips? No, I suck at physics, man. I'm sorry. I'm trying to figure it out for myself. What type of physics are you studying? You didn't even study? Oh, well, okay. Studying it is a good tip. A T over V naught. Okay, yeah, that makes sense. Hmm. You called it, Cook. It's easy to see from a V versus T graph why the ratio is 2. The area under A's velocity curve. Oh, that's an X versus T. Oh, okay. So if we did go through trouble plotting the velocity, you can just compare the areas because the area is the distance traveled. Okay. I didn't do all of them, but chapter 1 actually has some really kind of cool problem, like no physics knowledge allowed, just like intuition, dimensional analysis only, and like taking limits. Um, so it's like stuff like this. So I did a good few of them, but like I kind of like that they're just like testing intuition and that type of stuff. So you know, class of chapter 1 of this book. Oh, nice. I was learning stuff in mechanics. Yeah. Yeah, um I definitely had trouble with all of those too, but they're pretty fun to like think about. What level of math am I on? Uh, well, I have a bachelor's in applied math. So the all math I was doing for my degree is we're doing like system differential equations. I finished all of math last year. I'm done. Don E. Yeah, there's no more math left for me to know. Uh, yeah, I graduated like 6 years ago or something. Bachelor's in applied math. Um, minor computer science, and then I'm working on applying to grad schools. No worries, because I'm a geometrical optics. Ooh, Good luck with that, jeez. Do a Minesweeper? That can be arranged. I don't want to do the biggest one though. Cause I'm just gonna take because the RNG of Minesweeper. It's gonna take too long to actually get a dub. I'm going slower than I normally would because I really don't want to mess up. No! This is RNG, man. I don't know if it's this one or this one. There's no way of figuring it out. All right. Right or left, guys. Take your bets. It's a physics accelerator program for non-physics STEM grads. Ooh. All right. Well, I'm going left. Damn it. We're getting a dub. But that's why Minesweeper is stupid. And you shouldn't play it. It's literally just impossible to like no matter how skilled you are, you can still lose because it's just RNG sometimes. There we go. Easily done. 35 seconds. Oh, that's a 2004 PSI Start program. Like, wow, that's a little out of date. Oh, that's kind of sick. Oh, because the you saying the recording one is a little bit too slow because of your internet, but you would have been right. I played too much Minesweeper. It's how I keep my hands occupied a lot of the time, but it's a stupid game. Me open up that link too. Oh, nice. Okay, I'll have to look more into these. Actually, because I have a tendency to recklessly close out tabs. Let me put these into a notepad. All right. So, do you know computer science things? I should. I've forgotten. Oops. Wait. I haven't done 2.6 yet. I was about to go on to 2.7. Oh wait, no. No, this is no. I did do 6. Okay. I've forgotten a lot of what I learned about computer science. I relearned the basics of coding. But there's a lot that I learned that I've forgotten now. Hey, Bode, how's it going? Doing pretty good. Thanks for asking. Object starts from rest of the origin at time t equals minus t. Starts with acceleration a. The second object starts from rest of the origin at time t equals 0. Not a fan of negative time, but okay. Object starts from rest at the origin at time t equals minus t and accelerates with constant acceleration a. Then x1, the one that has a head start, has constant acceleration. It starts from the origin, from rest, so it's 1/2 a t minus big T squared. Viv, it's going good. How about you? Just practicing or trying to relearn some mechanics. How far apart are they at time t? Delta x is maybe a little confusing. So maybe we'll do x1 minus x2. Ooh, it's probably gonna be able to multiply this stuff out. ATT, hashtag ad. This book is sponsored. I used to think Pac-Man was a Taurus. Turned out to be Klein bottle because the Pac-Man disappears from the top left and appears to the bottom right. Heavy day at work today, been here since 6 a.m. About to leave in 15, just having a late lunch / e-bunch. Wow. That's a long day, Viv. Glad it's almost over at least. These two things go away. No, those don't. I'm about to say these two interact, but they don't. So this is it's linear. Gonna have some weed today? Nice, that sounds perfect. To relax a bit. So I think this answers the first question, how far apart they are. Explain the meaning of the two terms in your answer, first in words, then also with regard to the V versus T plots. Well, 1/2 AT squared represents the head start that the first object has. But then the distance begins to decrease as the second object accelerates and catches up. And since this is linear, why does it make sense? So if it's linear, doesn't that mean that x2 eventually, like the second object, eventually gets ahead of x1? That doesn't make sense. Hey, Edison, how's it going? Like, I feel like this thing should level off. Hmm. Does it? I think that's what you're supposed to represent. I need to look at a generic parabola here. Hoo-hoo, hey! Oh my god, Desmos. How you doing, hoo-hoo? If I have y equals x squared, and I have y equals x minus 1 squared, x plus 1. So the same parabola, but one is shifted to the left. My intuition says this blue parabola should always stay ahead of the red parabola no matter what. Is that actually true? It seems like it. Like, it's going to get very close together. I'm doing good too. It's been relearning some physics. Yeah, so what I'm confused is that the equation of the line that I get was basically me doing this. Oh. Well, that seems okay. I get... Did I mess something up? It's just that this thing I get seems to imply that they intersect because it's a line that looks like that. And so going from positive to negative would mean that they intersect. Yeah, you're right. That should just be 2x plus 1. I'm just wondering why this seems to be different. Oh, wait. This should be a plus, shouldn't it? That was the cause of all my woes. Hey, Alvito. I think this is like, maybe I was interpreting that wrong. Time t equals minus t. The negative time is maybe throwing me off. That makes more sense for the end result. I still don't quite get how t plus t. I guess. Someone else was riding a horse that wouldn't stop. You just joined. Isn't this x2 minus x1 before I changed it? No, I think I had it right. I don't get why it would be plus t either. It makes the answer make sense to me. I have this really difficult question. What is negative 1 to the power of 1 over negative, like 2,500,001? uh, I don't know. Does a What does Wolfram Alpha say that is? Because I don't know. A fraction of exponent of negative 1 is a dangerous thing. Hey, Obi. 2, 5, 1, 2, 3, 4 zeros into 1. Apparently it's negative 1. Because it's an odd root of negative 1, I guess? You could equivalently write that. It's going good for me. Hope the same for you. Of that, which is just negative 1, I guess. Okay. Teacher is something else. Oh, yeah, you can like also talk about a mod too. Okay. So how do like what's the interpretation of that negative t then? Because I think it is supposed to be t plus t squared. Um, so when t equals 0, this thing just started. This thing is 1/2 at squared, which is what we expect. Negative exponent doesn't do anything to 1. Yeah. I can ask questions, I'll be uncomfortable and I won't be mad. Proceed to ask questions, teacher gets like half mad. Oh no. Ugh, that sucks, Lucas. I still don't get why it's not minus t. This will maybe something to look at the solution for. But I feel like it is supposed to be plus t the more that I look at it. hope that's enough to say. I feel like there might be something more that you could say here. Maybe I'll just go with that though. So basically it's just that I really have to start and understand how to deal with the other type of questions, like how it's called. X1 is acting as a second object starting from 0. Shouldn't the order be reversed? Well, X1 is always ahead of X2, so I just took the bigger one first. But I think it doesn't matter which one goes first, because you should just, it would be a good part to take the absolute value. Because they're just asking how far apart they are. A right shift of this thing feels weird, but I think it's what we get. I think if maybe x2 was t minus t, this thing would work. It's literally translated as insight exercises. Yeah, I'm not sure what that could be, but hope you sleep well. See you around. I guess they say we also need to make some v versus t plots, so let's look at that at those. V1 of t is the initial velocity is 0. So it's I assume we're going to do t plus t again. This one is just at. And so that t plus t does give us the expected velocity plot, because v1 should have a head start here. But they have the exact same slope. This exercise is basically the exercise where Johnny rides his bike at 89. Big toe of 5 centimeters in width. That's a big toe. Oh, it's like a word problem is some way how we would call it in English, I guess. Where they give you a situation and you have to figure out what the equations are. So then also with regard to the v versus t plots. So maybe this is equivalent to the first object being given a head start. Well, obviously it's equivalent to the first object being given a head start. It's actually equivalent to the first object being given an initial velocity. Is what it's done. It has a running start. If they both start at the same time, you can make an equivalent situation. Oh my gosh. You could make an equivalent situation in terms of position if you gave the first object a running start, v of 0 not equal to 0. rather than giving it a head start, which is, I guess, x of 0 not equal to 0. I think maybe that's what they're going for here. This one website is just called, I'm going to try to pronounce it just for fun, Inviskund Effening. A math problem. Questions like that are called Vragstuken. Really little translation is question pieces. Huh. Funny. Yeah, I think we would just call those like word problems, I guess, where you're given just like words rather than like numbers. Hey, Phobos. Any plans for the weekend? Tomorrow, my friend is gonna have a poker night for his birthday. So I'm gonna be doing that. None of us know how to play poker properly. So we're just gonna like, I think you want everyone to spend like $20 or something that's like small like that. And we're just gonna like doing it for fun. But yeah. The entire Dutch vocab sounds like a fetish. Oh, dude, you're into Bragstuken? You're nasty. Can't believe it. It's okay. We don't kink shame here or Dutch shame. You can have whatever weird fetish you want. Good night. On that note. Ugh. All right, what's the answer for number 7 here? Okay, it is T plus T. Can I Dutch shame? You can Dutch shame Viv. I won't. Maybe that's the compromise. 1/2 ATT. Wait. That's not right. No, it is right. Okay. That does match my answer. I just had it. I had the flips, or I had the terms flipped. Texas Hold'em, Phobos. So I use Imperial System. Feet are better. That might be the best positive term I've heard for the like Imperial system. If you're into feet, it's just perfect. There's tons of feet. But yeah. We're gonna be playing Texas Hold'em. We've been playing a little bit of it just on this random website, so we've gotten used to like, the rules for like split pots and stuff are super. Like, there's some really weird rules it seems in Texas Hold'em that we don't understand. But like the basics of like what hand beats what. Like the high card acts as like a tiebreaker. And then like how the actual turns work, like you can just keep on checking, but if someone puts chips in, then you have to like do a round of everyone else either folding or putting chips in to match. Let's play Texas Hold'em with your friends. Ooh, nice. Like, how good are you at it? Or like, we're all just like, how seriously did you all take it? Try playing 10 card poker if you have less than 6 people. You have 5 in hand and 5 on the board. Really? I haven't heard of that. You're bad to the bone. You always lose my money. Oh no. Yeah, I mean, I'm going into it just expecting to pay $20 for a good time. That's the way you know, paid about that much for a ticket at the movies. So I don't care if I lose it all. I mean, I guess a movie ticket is a bit cheaper unless it's a fancy theater, but makes me, yeah, it seems like it, Viv. Like, I feel like everyone's gonna have a hand all the time. I don't know how many people are gonna be there. Might be like 5 or so of my friends, and then the dude's brother is also inviting some friends. So I think there'll be around 10-ish. A straight flush versus quads. Oh my god. Time to pick up Balacho. My friends told me about that. I've always I don't like the video game card games. I've never like really looked into much. I sold them as the most fun. Yeah, I mean that seems like the most popular like variant. Hey Joel. Silly pulls. Okay, so that was the something more that I was looking for to say there. $2.15. Right. Oh, neat. You can get the same thing up here geometrically from the V versus T plots. Okay. Auroras are out tonight in England. Check local conditions. Ooh, that's awesome, Moby. So remember this. Multiply outs by 4 on the turn and by 2 on the river for a rough probability. Use a GTO. I don't know what outs are. The river, is that after the 3 cards are put down? Oh yes. my my friends and I's issue is that we bluff too much, I think. What's my latitude? Can I quickly, okay, let me, like, can I just Google what is my latitude? And I know I'm not showing it. Type of place name. Latitude is 37 degrees. Three to 10 seconds, shutter open, yields giant ribbons across the sky with brilliant colors. Nice. Igloo. I just messed up the definition of a normal subgroup in my quiz right now. Oh no. I hope the rest of it goes well. Or like went well. Out are basically the cards you believe make your hand better. Oh, okay. If I can, I can actually walk to the 54-degree north line. A bit far, but still. Okay, good to know. I live a bit south of San Francisco. maybe like an hour or so drive, I guess. Fresno? Ooh. Godspeed, Igloo. Serene Submarine, with the catchiest name I might have heard. Thank you for the follow. Serene Submarine. Just rolls off the tongue. Is family there? Oh, cool. An object is dropped from rest. Show distances fallen during the first second, the second second, the third second. Ratio of 1 to 3 to 5 to 7. I mean, we can take down this positive. May as well. The distance has fallen. Okay. So we have to take some differences here. I wonder if you do this inductively or something to actually show it. But we're gonna want x1 minus x0. That's gonna be 1/2 g. x2 minus x1 is 3/2g. Ooh, there's the 1 to 3. x3 minus x2 is a number 5/2. Aha, there's 3 to 5. This is 7/2. Hey, okay. So these are 1 to 3 to 5 to 7. But I like engineering. I haven't actually studied engineering before. I imagine I wouldn't like how much they glaze over why things are the way that they are. Like, I think, like, I remember Merriweather saying how he was just given like a table of Laplace transforms and told not to think about where they come from. And like that would kind of like bug me. But maybe if I gave it more of a chance, I would like it more. But I haven't liked getting that applied so far, at least. When I first applied to college, though, was for engineering. I just switched to math after the first semester. So if we improve this in general, what if we want to show like x of n plus 3 minus x n plus 2? Well, we can do t's. Divided by x of t plus 1 minus x of t, say want to show, is equal to some odd number, 2k plus 1, where k is an integer. It's probably getting a little too mathy for this physics book, but I think this is how we would show it. Posted a question about hard determinant on Discord. Oh, sure, Alex. Thank you for calling that out in chat, because I don't always see my Discord when people post problems in there. Oh, I see that BB posted one in there too. I don't know if I'll be able to do it, but I'm gonna look at yours, Alex. First. It's a problem from an exam, first year learning algebra. Can you show me how I solve it? Oh no. For a natural number n with n greater than 2 or equal to 2, the following matrix is given. Okay, so this is an n by n matrix. The matrix exists in the space of n by n rational numbers. The matrix entries not explicitly shown are all 0. Wait. Does that mean like this diagonal is 0 in between these twos? That seems weird. And this diagonal isn't ones but zeros? Show that for all n greater than or equal to 2, the diagonals is 2? Okay, the statement seems poorly phrased then. Show for all n greater than or equal to the following holds. The determinant of a sub n is equal to 2 to the n minus negative 1 to the n over 3. And develop the determinant using Laplace expansion. What is Laplace expansion? Oh, it's okay. Is that where you cross off a row? Yeah. Okay. So that's the way I was taught to take the determinant. Well, okay, so I want to draw a sub 6 here, because I feel like this definition of a is confusing. So 2, 1, and then all 0. So 1, 2, 3, 4. 0, 2, 1, and then zeros. 0, 0, 2, 1, 0, 0. We need 3 more columns. 1, 2, 3, 2, 1, 0. 1, 2, 3, 4, 2, 1, and the last column was all ones. So I guess this is what a sub 6 is. I just really... The thing that has me like worried is that weird phrasing with like these dot dot dots being zeros. That doesn't seem like they should be, or it doesn't seem like that's their intention, but their phrasing doesn't say that to me. Well, I was drawing A6 specifically just to show an example. But yeah, for like this is like a generalized matrix where n can be anything. Unless I'm misunderstanding, and okay, it's correct. this feels like there's an induction here. Because I assume what they want us to do is eliminate along this top column, or this top row. And we're going to find that this matrix here is an exact copy of the bigger matrix, just slightly smaller. I think that's what they want us to do with this Laplace expansion. So this feels like induction to me. So if we want to go with the base case, n equals 2. That's also what you thought. Okay. Two, one, 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 like that. I guess the determinant. It's equal to 1, because 2 minus 1. 2 squared minus -1 squared over 3. That's 4 minus 1 over 3, which is 1. So that checks out. Step 2 of induction. A sub k. 2 to the k minus -1 to the k over 3. 2, 0, 1, 2. Oh, you're right. Thank you. Doesn't that screw this up then? Are you sure? No? It should be a 1. Like, I was treating it just like that little matrix right there. But it's because, like, this diagonal being 1 should make that a 1, I think. I mean, you're right. It's a little bit ambiguous, though. Like, I could see what you're saying there with it's supposed to be a 0, but if that was a 0, then this formula wouldn't work. So I think it's supposed to be a 1. Because we would get a 2 for the determinant, and then the formula would give you a 1 still, so. Now we want to prove that the determinant of A sub k plus 1 is equal to 2 to the k plus 1 minus -1 to the k plus 1 over 3. Okay, so the determinant of a to the k plus 1, or I'm sorry, not a sub k plus 1, not a to the k plus 1. That'd be a much harder computation. Is, I mean, we basically are going to repeat this. Let me just screenshot that. Or not screenshot it, but like copy it. And then if we eliminate along the top row here to start doing this Laplace expansion, we're going to get 2 times the essential thing to notice here is that this orange minor matrix is a sub k. I assume that's the point of the problem. But we do have to deal with the matrix we get from the 1 that I'll do in blue here. And that 1 is also going to have a sign. -1. It's the 0th row in the kth columns, or k plus 1th column, so -1 to the k plus 1. Times the determinant of that. And I'm hoping that we can work some magic here to show this thing is hopefully 0. Actually, no, it doesn't necessarily have to be 0. We might not want it to be 0. How can we analyze this thing? This seems like a second proof by induction, to be honest. We do have to do it. Yeah, I think we have a sub problem here for a proof by induction. That's such a pain, dude. Because now the main diagonal is all 1s. I mean, is there something quick we can say about the determinant of a matrix where, like, the main diagonal is 1s, and that lower diagonal, or that lower triangle, is 0s? Like, is there, maybe there's an identity there? Oh! The determinant is the product of the diagonals. Do you have this as a fact? That'd be great if we can use that. It's called expansion matrix. Okay, this might not be too bad to do by induction either if you don't have this fact. But I think what we're going to get is that the determinant of this matrix is equal to 1 times 1 times 1 times 1, however many 1s we have, k plus, or I guess k 1s. So if you don't automatically have this as a fact, then I guess maybe I won't assume that you do. We can try and do a second proof by induction to show that. Running out of space in this paint. Let me get rid of this A6 and we'll do it up here. Okay, so base case with n equals 2. Our base case, I think, is going to be this matrix here. Yeah, you can multiply the diagonal. They're only zeros. Oh, okay. So if you have that, do you have that as a fact? Because if we don't have to prove it, that would be fantastic. Because like what I want to do is just go right on the problem. Okay, good. So what we can say is that the determinant of this thing here is just 1 to the k plus 1. Because we have k plus 1 many ones in that diagonal. And then we can use the induction hypothesis on that determinant ak. Two to the k minus 1 to the k over 3 plus minus 1 to the k plus 1. And then hopefully this works out and gets us that right there. So when we distribute the 2 inside, we get 2 to the k plus 1 minus 2 minus 1 to the k over 3. And that negative 1 on the right, we're probably going to need a common denominator. So let's do 3 times minus 1 to the k plus 1 over 3. 2 to the k plus 1. So now if we factor out a minus 1 to the k, a negative minus 1 to the k, we would get positive 2 minus 3 times negative 1. Over 3. Does this work out? Oh, wait. No, that's just 5. That's not what we want. If we factored out instead a k plus 1, or negative 1 to the k plus 1, that's actually what we would want on that term there. So it'd be 2 divided by negative 1 minus 3. Well, that's negative 5, though. No! I want this thing to be equal to 1. Minus 2 minus 1 to the k, or plus 3 times minus 1 to the k plus 1. For an even value of k, we get negative 2 minus 3. I guess I messed up a sign? Oh wait, is there an easier way? No. Well, there is an easier way somewhere. I'm just not seeing it right now. Uh... Oh wait, is this supposed to be k plus 2 here? Oh, it's because we start counting from... Okay. I'm counting from 0 because I'm just being weird. But the factor you get in front is -1 to the I plus j. I thought I was 0 for some reason. But I is 1, and j is k plus 1. I think. So it's 1 plus k plus 1. And so that's k plus 2. And -1 to the k plus 2 is the same as -1 to the k times -1 squared, and -1 squared is +1. So -1 to the k. Let's see if that fixes this. I hope it does. So if we factor out a -1 to the k from this, we get 2 minus 3. Aha! Okay, this is good now. Because 2 minus 3 is -1. And then we just add the exponents. -1 to the k plus 1 over 3. Bam! Hey, Delamorte. Yeah. All right, does that make sense, Alex? Sorry, I messed up that little term up here, but caught it eventually. You can explain what you did shortly? Yeah, sure. I'll re-explain it. So, and I've been here long enough. Oh, I'll show the original problem here, Delamorte. I'm going to explain the problem in a second, though, so if you want to really have a copy, then take a screenshot or something. But yeah, I was doing this by induction. I'm going to scroll away. So the base case, I think we're on the same page for. We start from n equals 2. This is this is the matrix for the n equals 2 case, and that has to be 1, because otherwise this formula wouldn't work. So we verified these things both equal 1, and we're happy. That makes sense. Good. Okay. So the second step of the induction is just to make the induction hypothesis, assume it works for some k. And then the third step is to prove it for k plus 1. How's engineering textbooks work in your own time? Oh, no worries. Also, okay, well, I'll wait to see what you type. Alex? That's a problem with the first step? Okay, yes. Sorry, I was like explaining from scratch, so I wasn't sure exactly where you you weren't sure. So yeah. So the thing we want to prove is that the determinant of a sub k plus 1 is just the same formula with k plus 1 in there. So we start by looking at the determinant of the matrix a sub k plus 1. I eliminated along the top row for the Laplace expansion. And because these are all zeros in the middle, we're going to get this 2 times this orange minor matrix. And then we'll get this 1 times this blue minor matrix. So that's how I go that's how I go to the next step to get that same 2 times the determinant of a sub k, because remember, this orange minor matrix is just a sub k. Like, I imagine this matrix as starting in the lower right, and with each k you go out, you add on another row and column like that. And that's how I'm building these in my head inductively. And so that's how we get the first term, 2 times the determinant of a sub k. This all the terms in the middle are 0 times something, so we don't have to care about them because 0 times something is 0. The last one for the 1, I didn't actually write it, but there's an invisible like times 1 here that is this one here. But since we're multiplying by 1, who cares? How I got this term right here is that when you do that Laplace expansion, each of these terms has a -1 to the I plus j in front of it, where I is the row number and j is the column number. And so this 1 is in the first row, so it's row 1. And this matrix we're saying is a sub k plus 1. So this is the k plus 1th column, because it's the very last column. So that's why I got -1 to the 1 plus k plus 1, because the k plus 1 is the column. And then we have that times that blue minor matrix there that we just kind of have to figure out how to deal with. And so as you pointed out, this is a triangular matrix. And for a triangular matrix, apparently the determinant is just the product of the diagonals, or the product of the diagonal. So it's not completely necessary to write, but I said that I made the claim that the determinant of this thing is 1 to the k plus 1. Since it's just 1, we could have just omitted that depending on your style, but the determinant is 1 to the k plus 1, and of course that's just 1. And we're multiplying by 1, so who cares about it? So I just drop it off in the next step. What also happens in this step is I do 1 plus k plus 1 is k plus 2. And then the -1 to the k plus 2 becomes -1 to the k. I think you understood that step. And then I use the induction hypothesis to say that determinant of a sub k, because remember, we assume that this is true, so we're allowed to use it here. So with that determinant of a sub k, we plug in 2 to the k minus -1 to the k over 3. So that gets plugged in there. Now I multiply the 2 inside. So it becomes 2 to the k plus 1 minus 2 times -1 to the k. And then from here, we just get a common denominator for everything and add them all together. So we factor out the -1 to the k from these two terms, and we get... oh, I'm sorry. I factored a -1 to the k from these two terms, because that like flips the sign in front of them. it's not that necessary, but it's the cleanest way that I saw. So the negative 1 to the k goes in front, and then we get positive 2 minus 3. And so we say 2 minus 3 is negative 1, and that negative 1 to the k times negative 1 is negative 1 to the k plus 1. So I hope that makes sense, Alex, but if there's still a question on like one of the steps here, please let me know where. And Delamorte says, I downloaded LT Spice yesterday and looking at KiCad. I don't really know if I have any other options as an independent learner. LT Spice I never heard of. I never heard of KiCad either. I know what CAD is generally. I definitely don't know anything about it though. Sounds good, Alex. Thank you for the question. That was a fun one. KiCad is a free circuit design CAD program. Oh, okay, nice. Sereno asks, where did the 2 go? There's a lot of 2s floating around here. If you mean this 2, I distributed it into here and here. But if you mean a different 2, then I don't know. Two to the k plus 1 to 2 to the k. Oh, ha. There's a typo there at the very end. It should be 2 to the k plus 1. I just miswrote it. Thanks for pointing that out. All right, so there's this. These look like competition questions, but let's at least take a look at them. I feel bad that this person posted them a little while ago and I didn't see it because they didn't say anything in chat. Oh, dang it. This is gonna be a crappy way to show it. Let me do it this way instead. Find all functions R to R. Put plus or minus looks more fancy. Oh, is there a plus or minus way to show that? I don't know what it will be. Yeah, these are these are like competition ones, and I assume I don't know what TST stands for, but find all triples of continuous functions f, g, h from R to R, such as f of x, y equals g of x plus h of y. Yeah, I don't know how to do these. it's like first step, x equals 0 equals y. Okay. I'm honestly not all interested in doing problems like these, so I'm just going to move on, but I know it's a common first step for those types of problems. And the tricks. Yeah. That seems to be the theme of competition things, where you either know the tricks or you don't, and I'm not really interested in learning them. So, in the meantime, I'm going to go back to the physics Stuf. And so, they're saying to show, or I think I've shown like a couple of examples for this ratio. Physics, bye. It's fair enough. I've been enjoying it, but I know it's not for everyone. I want to see if I can show that. I don't know exactly what they mean by show, but I kind of want to do something that's a little more proofy here. See if these ratios are an odd number. Came back. Oh yeah, it's because there was a person in the YouTube chat who needed help with the question, but I'm going back to like the little like downtime activity here. Was my expression for x 1/2 gt squared? So this particular question might be another induction, if that excites you, but one half gt squared. Can you tell me how Lebesgue integrals work? I don't know Lebesgue integrals. I'm sorry. I never studied them, Alex. I've heard like a metaphorical explanation. That was kind of neat, but I didn't fully understand it. Yeah, I've heard it kind of described as the opposite of a Riemann integral. Yeah, okay, this is the thing that I was thinking of. Spacer and so much I have collected in my pocket. I take the bills and coins out of my pocket, give them to a creditor in the order I find them until I reach the total sum. That's the Riemann integral. I can see it differently. After I've taken all the money out of my pocket, I order the bills and coins according to identical values. Then I pay the several heaps one after the other to the creditor. This is my integral. So that's like a metaphorical explanation of a Lebesgue integral. You do things by, rather than splitting it up by the x values and taking a delta x, I think you split things up with the y values. I've never have actually studied these things, so I don't actually know much more than that. What is in effect partitioning the range of f? The Wikipedia page is actually pretty approachable here as far as Wikipedia pages go. The cumulative COVID-19 case count from graph of smooth cases each day. Oh, that's Kind of cool. So our COVID cases in Serbia from summer to fall of 2021. Huh. Oh. Interesting. So here you're choosing different types of blocks of a fixed height and seeing how many you can fit underneath the curve, I guess. And I guess you're allowed to play with the width as much as you want. So yeah, that's as much about I can say, Alex, but I don't really know anything else about Lebesgue integrals, unfortunately. I think Lebesgue integrals are motivated from measure theory. I think so too, Serena. I've even seen the resources on that page where you need like to define a measure or something like that to make it work. But I don't know anything about measure theory either, so. Oh wait, am I doing this too complicated? I think I am. No, I'm not. Can we say what form? Like, can I be more specific than just any odd number? Can I say it's a particular odd number? So like from x equals 0. Oh shoot, I didn't even set this up right. It's not like that. It's like this. And so we ended at 2, we got 3. We ended at 3, we got 5. We ended at 4, we got 7. X is a function of t. Basically, it comes from a physics situation, but feels more like a math problem where if you drop an object, so it looks like that, the position or the distance is falling in the first second, and we're partitioning it into each second. And I think what they're saying is like the difference between the start and end of each of these intervals follows a ratio of odd numbers. So I manually calculated the distance traveled during each of the seconds over here, and they do like, you know, this is 1 to 3, 3 to 5, 5 to 7. But I'm interested in trying to show that in general. And I think the pattern, well, the g over 2's cancel out if we actually take the, if we actually like divide these. I think the key is it's always this like shared term. It's twice that plus 1. It's like 2 times 2 plus 1 is 5. 3 times 2 plus 1 is 7. So I think I can be more specific on that right-hand side and say this thing should be equal to 2 times t plus 1 plus 1, which is equal to 2t plus 3. And I assume we can actually show that if we multiply some things out here. That'll be k squared for k terms. I don't see that approach. 4t plus 4 minus t squared minus 2t minus 1. T squared plus 2t plus 1 minus t squared. T squareds cancel 2t plus 3 over 2t plus 1. That's not good. Sum of odd numbers. Wait, the sum of the 1 plus 3 is 4. 1 plus 3 plus 5 is 9. What the hell? I never knew that. 1 plus 3 plus 5 plus 7 is 16. Okay. I didn't know that the sum of the first odd numbers is just k squared. Or the first k odd numbers is k squared. Or, yeah, I guess we have to be a little bit specific, but like, I guess it's 2k terms. I could see how you could do it with the, I guess you could probably do it with the Gauss's sum. Can you though? There's probably a way to make the Gauss's sum thing work. Just weak induction? Oh, okay. Oh, duh. Okay, no, I don't expect, I expect this. And I think I show that. Okay. That's what Showbot would say. Yeah. Showbot just won't shut up sometimes. All right, what did they say for 2.8? The v versus t plot shown in figure 2.16, the area under the curve of tilted line in this case is the distance traveled. The number of identical triangles in each interval of time t. Oh, that's a neat visualization. There's one triangle in this partition, 3 triangles in this one, 5 in this one, 7 in this one. Huh. I like that. Only 3 more questions in chapter 2. Balls dropped from rest at height h, directly below on the ground, a second ball simultaneously thrown upward at speed v naught. Two balls collided on the second ball is instantaneously at rest. What is the height of the collision? Oh my god. What is the relative speed of the balls when they collide? Draw v versus t plots for both balls. Sum of odd squares, there's a formula for that as well. Really? Prove by cases it'll always divide 3. Oh. How does that work? Four I squared. Wait, really? Oh, they just really multiply out the 2i minus 1 squared. Oh, okay, so you can really just subtract all these. And I assume get the result that you say, Serena, or something like it. In my country, they teach arithmetic and teach us to find a formula for every sequence up to third order. There's a way to find any order n. Right. I've looked at a problem. I remember looking at a problem that involves that, like for any order of n. I don't remember exactly how it works though. Cool. And like to prove it by cases, you'd take like n equals to 3k, 3k plus 1, and 3k plus 2, I guess. It uses permutations. That sounds right. What is sum of natural numbers to the n? Sum of that's not a good thing to search. Sum of net maybe to a power? Sum of powers. There we go. Fallhabers. Yeah, you need these Bernoulli numbers that I've heard of but don't know much about. Nice. Here from is sum of divisors of any natural number. Really? Sum of divisors of natural number. I haven't heard of one for that. Huh. That's kind of weird. But I guess so. It's p to the k minus 1 over p minus 1 and so on. Hmm. So the proof is by combinatorics. Oh. Okay, yeah, this looks like the formula that Bode is writing there. Weird. Oh my god. This is just the crazy explanation, if you just feel like it. Wow, and you get that weird sort of alternation. Positive, positive, negative, negative. It's complexity at least big O of n, which makes it kind of useless for practical purposes. The lack of reference to divisibility in the formula, which makes it a bit miraculous and therefore worth mentioning. Huh. Tidu's lemma. Let's see. Go away. Oh, wait. Oh my gosh. Okay. Can I zoom out? There we go. Andrescu's name showed up on the wiki. He's a legend. I don't know who that is, actually. Positive reals A1 through AN and B1 to BN. Oh. I can see how this would be helpful for those inequalities that you're so good with, Bode. It's a direct consequence of the Cauchy-Schwarz inequality. He's famous, but he steals a lot. This is basically stolen as well. He just attached his name to it. Oh, it's called Angel's form of Cauchy formula. Oh, okay. I was interested about that Engels form. I know, I think it's a German for angel. Okay, yeah, this one I think I've seen. Seems for IMO, I think. That's cool. Okay. Let's start with an x versus t graph. This one will be orange. The other one will be green. He is very strong with math. My deceased professor was from there. Oh, wow. I didn't know that. Okay, so I try to make it so that the vertex of this green parabola is at the same point as where that orange parabola ends. It's probably not proper to draw the entire parabola. Because what happens after that, you know, we're not going into, because we're not doing momentum yet. What is the height of the collision? Well, it's equal to h. There's no initial speed, so just h minus 1/2 gt squared. This one has initial speed v naught. 1/2 gt squared. And then I think we equate these two things. Do we? I guess so. But if they collide with the second ball is instantaneously at rest, do we really even need to know that? Like, can't we just figure out when this ball is instantaneously at rest? Wouldn't the question should have been like, what should V naught be so that, or what's the relationship between V naught and H or something? What is the, if the two balls collide at the moment the second ball is instantaneously at rest, what is the height of the collision? Okay, let's do it the physics way. I'm thinking of a math way, but I think the physics way would be to look at the velocity of the second one and say it's v naught minus gt, set it equal to 0, and see that t equals v naught over g for when basically it gets the height of the thing. Does that, I was going to do minus b over 2a here. Does that also get you what you want? It does. Yeah. Okay. So the height of the collision v naught squared over g minus. I feel like I've done this exact same calculation a million times now. And let's check. And theoretically, x1 needs to agree. Well, not theoretically, just does need to agree. Does that mean h equals, wouldn't h have to equal v naught squared over g? That seems reasonable, I guess. I don't see why not. Like, the height of the collision is v naught squared over 2g, but the ball starts from v naught squared over g. First one. The relative speed of the balls when they collide. We need to figure that out. Well, we know that v2 is 0. V1 is going to be whatever gravity is doing. So just minus v naught. So v1 of v naught over g minus v2 v naught over g to get the absolute value. It's equal to v naught. That's the relative speed of the balls. Some of them just at rest, so I don't really know what else they want. V versus t plot. So the first ball starts at 0 and has negative velocity. The second ball has positive initial velocity. But then it decelerates, or it loses speed at the same exact rate, right? Yeah. Okay. So there's probably some geometric... I mean, can we figure out the geometric interpretation before we look at what the book does? Actually, I guess these shouldn't be arrows if we're being picky. They're not certain. We're just kind of not considering what happens after they collide, so we're just going to kind of cut off the time after a certain point. I'll just look at the answer. What was this one? Number 9. Hey, hard locked. Just never gets old. Wait, what? Oh. Wait, well, I mean, I just kind of skipped ahead to the equation being at t equals v naught over g. They give you that it happens when the ball is at rest. I guess you can do this thing first if you want to be more general. Yeah, okay, I guess that's what they're doing. V naught must be given by v naught squared gh. Is that what I said? Yes. And so the height the equation happens as h over 2. Is that what I said? Yes. in different words, but same thing, or a different representation, but the same thing ultimately. Two velocities are given by, yep. That's just knowing when the balls collide. Okay. Oh, no, it wasn't so bad. And thank you, Hardlocked, for the biddies. Appreciate you. Hitting at the same time. Balls drop from rest at height h, and their balls simultaneously thrown downward with speed v from height 2h. What should b be so the two balls hit the ground at the same time? Well, I guess we'll do our old reliable here. H minus 1/2 gt squared. X2 is 2h minus vt minus 1/2 gt squared. And when does this thing equal 0? Which it's a... What time that equals 0? We'll plug that same time into here, set it equal to 0, and solve for v. Okay. What a messy difference of two squares this thing is. We're going to want the first case. Why would I rationalize it? That just seems silly. Just say root g over 2. So this is going to be root 2h over g is the time that we want when it's going to hit the ground. So now we're going to take x of root 2hg equal to 0 equal to 2h minus v root 2h over g minus 1/2 g times 2h over g. 2h minus v root 2h over g. Isn't this thing just h? Is that what's happening? Yeah, it looks like it. So we'll get h equals v root 2h over g. V equals h root g over 2h. Oops, 22h. 2h. This feels like a stupid number. H over root h is the same thing as root h. This is a slightly less stupid number for no real reason. Okay. I guess I'm saying root GH over 2. Let's see if that's right. Yeah, Teratar. Nearly through with chapter 2 on one-dimensional kinematics. The book has some really good questions that have been giving me trouble. Okay, root 2h over g for the time. Good. Root gh over 2. Nice. If doing any calculations, the consideration of units tells us that the answer must be proportional to root gh. Fair enough. No double spring pendulums. No. Thankfully. I think I did have to do those in my differential equations. Like the more advanced differential equations class, though. Always stuff like that. CXMR asks, what's the difference between differential equations and partial differential equations? That's a good question. So I've only hardly studied PDEs, or partial differential equations, but like the simplest way to explain it is partial differential equations have multiple variables involved. It's like it's like the difference between like Calc 1 and Calc 3, where you go from just x and y to x, y, z and higher. I imagine the same difference exists for diffie-q and partial diffie-qs. So you know like what a partial derivative is. That's where it comes from. Yeah. And so I think PDEs are pretty, like, I imagine ordinary differential equations is pretty like well known, or like we figured a lot of that stuff out, but PDEs are pretty like actively still like worked on. Tartar on YouTube says heat equation is a good example of a PDE. The rate of change of heat with time depends on the rate of change of temperature with distance. Right. That's one of the few PDEs that I have studied. It was a long time ago though, so I hardly remember it. Let me not look to Wikipedia for a good explanation. Yeah, like this is the representation that I remember seeing for the heat equation, where the rate of change of heat with time depends on the rate of change of temperature with distance. That's what this thing says, where U is temperature or heat. I'm not sure if the difference is important, but the rate of change of heat with time is equal, or at least is proportional to the second partial derivative of heat with respect to space or distance. You're taking diffie-q right now. I heard partial is harder. I feel like my friend's making the class too easy. Oh, well, if it's too easy, as far as I know, PDEs go pretty hard. I normally think of that as something that's reserved for grad students, though. I just have a bachelor's, and for my degree, I did differential equations and then 2 semesters of more advanced differential equations, but those were mostly still ordinary. We like barely dipped our toes into the heat equation and the wave equation. I don't remember exactly what the wave equation does, but something. It was more about, and I think it was super cool. It was more about modeling differential equations and like systems of differential equations. Teaches through mimicry. Every test question, like the first, second example, he shows us for each topic. Oh, okay. Yeah, if he's just teaching you like the step by step, that's definitely not as much fun. That's kind of how I always thought diffie cubes, and that's how I still know them. So use a note card like, bro, give me a reason to come to class. If you're interested in hearing a bit more about the why of differential equations, and Simplex Pachinko did a whole class on Twitch recently about diffie cubes. And I believe he highlighted all of those classes, so they'll never expire on Twitch. So if you look at his VODs, I think there'll be a section there for the class. So if you're ever interested in like hearing a bit more about like why things about diffie cubes are the way that they are, then that's why. Hey, Obi. Yeah, they're hide awesome. So yeah, CXMR there was just asking about like the difference between ordinary differential equations and partials. So I kind of related it to going from Calc 1 to Calc 3 with from X and Y to X, Y, and Z in higher dimensions. In a collection, awesome. But yeah, I know some things about differential equations, but if you want someone who knows more than me, then Simplex Pachinko there is a very good person to ask about them. All right, so I think we got 10 right. So let's get to the last problem, chapter 2 here. Take partial and nonlinear. I did not. I did a normal differential equations class, which was just like ordinary differential equations, and then I did 2 semesters they called methods of applied math, which was a tiny bit of PDEs with a heat equation and wave equation. I don't think we did nonlinear at all, as far as I remember. And then it was like systems of differential equations and like the linear algebra connection and like applications of those. Okay, now I have an evolution of the last one. This is the last one, right? Okay, yeah. So it is fallen a distance d, the second ball is dropped from rest at height h. Should d be in terms of h so that the balls hit the ground at the same time? Should d be in terms of h so the balls hit the ground at the same time? Interesting. Whenever things don't happen, like, it's always hard to deal with things that, like, is when one thing is given a head start. So how do we want to deal with it here? What we can do is figure out what the first ball looks like as the second ball is dropped, which, you know, balls dropping will always make me giggle, but a second, so it's dropped from height 4h after a distance d. We should be able to figure out for a given distance how much has this thing accelerated, right? Or like what the velocity of it is. And we do have the equation vf squared minus vi squared is something. 2 root 8 or 2, okay. It's just 2AD. And are these D's the same thing? God, do balls and D's everywhere. Yeah, they are the same thing. And we know that VI is 0. So, oh, and A is G. Root 2 GD is the velocity of this thing. So that means the position of the first ball at any time, it starts at we're considering it at time 0 to start with height 4h minus d. It has an initial velocity root 2 gd times time minus 1/2 gt squared. And then x2 rests at height h. So this thing starts at h. It starts from rest, so just h minus 1/2 gt squared. So we want the balls to hit the ground at the same time. It's terrible when your balls don't drop at the same time. Should d be in terms of h so that the balls hit the ground at the same time? Okay, well, we know when x2 is going to hit the ground, and x1 is what's going to adjust. So let's figure out when x2 hits the ground. That's the same exact thing as in the last problem, was it not? We get this ugly difference of 2 squares. T equals 2h over g it was. Yeah. So we're going to take x2 of root 2h over g, set it equal to 0, plug in our thing. 2gd times t is root 2h over g minus 1/2 g 2h over g. Okay, and now we solve this for d. 4h minus d minus 2, the g's cancel, root gh. What a terrible g. You should be ashamed of yourself, g. You're not even supposed to be a g. You're supposed to be a d. Okay. And then that's just an h. Oh no. That d being, we have 2 d's. God. Anti this virus. Are you familiar with second order non-homogeneous ODEs? Yeah, I'm a little bit rusty, but if you have a question, feel free to drop it. You can put it there in chat, or it looks like you just hopped in the Discord, so you can post it there too, if that's easier. Second order non-homogeneous ODEs. So remember, you do the characteristic polynomial for the homogeneous solution, and then the particular solution. Oh yeah, undetermined coefficients or variation of parameters. Okay. Yeah, this is where differential equations get kind of annoying. We can do it though. Actually, you know what? Let me not go to paint yet. Actually, I wasn't even showing the paint anyway. Copy link. That's your work. Thank you for showing that. Ugh. Copy link. Hey, Fembox. How's it going? Okay. Oh. Okay, so we're given the fundamental set of solutions for the homogeneous. Okay, that's helpful. uh, it's very rare that I do these with non-constant coefficients. Oh, you here? All right. Hey, Fembox, welcome in. See, if we're given the homogeneous solution, hey Zach, how do we get the particular solution? What's true about the particular solution? It's an Euler equation? Yeah, this form seems like something that's known. Let's look at what you did for your work. Oh, you do have the right idea for like, this is just the homogeneous solution though. I wouldn't plug in your initial conditions until you also get the particular, because I think that's going to mess up what your C1 and C2 are. But I'm going to expect there to be another term added onto this for the particular part. I just remember how that actually works. I don't know if Paul is going to go over this part of differential equations. Assume y equals x to the r. I'm just going to look up Euler equation. Oh, Paul does go over these? Oh, okay. What about non-homogeneous? Like, for non-homogeneous, can we just do, like, would we just guess that it's a fifth degree polynomial? I feel like the coefficients being different make those guesses not quite the same. Hey, Anders. Okay, let me... Okay, here's a non-homogeneous variation of parameters. Yeah. I'm just wondering... So I don't think we need the x to the r thing when we're given the homogeneous solution already. So I'm really just trying to deal with the particular part here. Okay, they're using variation of parameters here. Okay. You two Anders, good evening. Really? So we have to divide everything through by the leading coefficient, which we can do. Ugh. Please just give me the general formula, or like, I guess that is the general formula, but this is an annoying version of the general formula. I want them to tell me what the Wronskian is and what this G thing is. They probably do say all that somewhere. Yeah. Just take this formula and make it simpler, please. I don't care how complex the problem is, just make it simpler. Oh, G is just whatever's on the right side. Really? Okay, so... I guess anti this virus, do you know variation of parameters? That seems like the play here. You're familiar? Okay. So I think it's what we have to do to get the particular part. We're gonna have to apply it here. So you need to how exactly, or I need to remember how you set up the Wronskian. Yeah, I think the top row is just the two fundamental solutions, and the bottom row is going to be their derivatives. Like that? Okay, yeah. Thank you, Zach. Oh, okay. Let's get this image into Paint. Okay, oh, like the line break? I know what you mean. Wrong skin. We do need to rewrite our differential equation. We need to divide everything through by that x squared to isolate the y double prime. We also need to not randomly change a 10 into a 20. $176 is such a weird number. Okay. The Wronskian is our fundamental solutions on the top row. And then their derivatives on the next row. 16 times 11. Oh, yeah, it is. Is that any less random, though? Maybe there's a reason why it's like that. 7 watch streak, thank you. And we'll welcome in Huiwika? And I'm sure that's a flawless pronunciation there. Negative 10 plus 6x to the negative 10. X to the minus 10. Is this cool? I think it's cool. Okay. That's our Wronskian. Now we're plugging into this beast of a formula. I mean, we're mostly caring about these first two terms. You already found the second two terms. Why is there... Okay, I shouldn't ask why there's a random negative in front of there. I'm sure I could scroll up and find out why. Let's just accept there's a random negative there. So the first term is... Actually, let's work out those integrals first. From x0 to x0. And is x0 whatever our initial condition is? So y2 g, y2 is x to the negative 3. G is this. Oh, that's kind of nice. Over the Wronskian, 3x to the minus 10. dx. Okay, well, 3 goes into 176, doesn't it? No, it doesn't. Okay. 176 over 3. That's just x to the 10th. Oh, I guess we do get an 11 here. 1 over 11 x to the 11. Went from x0 to x, but that x0 to x thing is kind of weird. I feel like arbitrary x0 is just an arbitrary constant. Okay, I'll believe you, random website. Never doubted a random website before, and I'm not going to start now. I put x naught twice. X to the 11 minus 16 over 3 x naught to the 11. Okay, that's the first integral. The second integral is the same thing, but with y1. And y1 is x to the minus 6. Right, yeah, g in the same routes again. 176 x cubed, 3x to the minus 10 dx. What happens here? I'm gonna do this integral in 2 steps. So we get x to the 7. So the dust settles with these exponents. Negative 3 on top times plus positive 10. Yeah, okay. Now we know how to integrate that. 176 over 3 times 1/8 x to the 8th, x naught to x. If 16 goes into 176, then so does 8. So we get 22 over 3. X to the 8th minus 22 over 3 x naught to the 8th. Okay. So evidently the entire solution is minus y1, which was x to the 6 minus 6, times the result of the first integral, this thing. Aren't we going to have 3 unknowns, though? How does that work? Plus y2 times the second integral. y2 is x to the negative 3. X to the 8th minus 22 over 3 x naught to the 8th. It'd be nice if we can just ignore them. I'm not sure either, though. Plus c1 times the first solution. Yeah, dude, I love that line. Spetry, you are the first to 18 months. Thank you. Holy crap, dude. Appreciate you. I think you were like the second person to sub to me, because I remember telling one of my real life friends that I got affiliate and he subbed. But I think you're like the first person to actually sub like on my first affiliate stream. Okay, so theoretically, this thing is our solution. What do we do with these x zeros? It only has two. Can be obtained with every choice of x naught by making the right choice of C1 and C2. Really? Oh. I think my friend might have beaten you. I'm sorry. That's how I remember it, at least. I mean, maybe I shouldn't have said anything. I should have let you live with... thinking that you were the first sub. Problem will be done. Yeah. The given solution can be obtained with every trace of x naught by making... Is C not... Are the C's going to be in terms of... They don't even... They just completely ignore the x naughts. We're given initial values at 1? Really? What initial values are given? These initial values are at 1. I don't know why, but... They're saying we just take x naught equal to 1, because that's what the initial given values are at. I guess we can do that? Sorry, this is, I haven't done an Euler non-homogeneous equation but before, so that's why I'm a little bit unsure of this this virus. You agree, though? Okay. A gamer recommendation? Okay. Hit me with it. See, I think because our initial conditions are 1, we for some reason can justify taking x naught as 1. I don't really know the details of this. I'm just kind of following with the procedure that the website says here. Thanks for double checking this, Pui. Sorry, I'm just gonna pronounce that wrong. 16/3. Void Stranger. On the surface, it's a puzzle game. Okay. And slightly deeper down, it's a game that tears your heart out and stomps on it. 22/3 x to the 5th minus 22/3 x to the minus 3. Nearly there. C1 x to the minus 6 plus C2 x to the minus 3 equal, we have x to the 5ths in common. 16 plus 22 is 38. Interesting, we do get x to the negative 6 and x to the negative 3 repeated. So we'd even group those, like... Oh, maybe that's why... Oh! I think I understand why this x0 isn't that important. Because... it's just going to change the C1 a little bit, but that's completely fine. So what I did is I took this x to the negative 6 and I grouped it with that x to the negative 6, and I noticed that this thing came from the x naught term. I'm going to do the same thing with these x to the negative 3s. Okay, and that's about as simple as I can write this solution, but we still have our initial conditions to contend with. You don't know you're still playing it. Some of the metal puzzles are too crazy. Interesting. Okay. Okay, so this, before the initial conditions, I think is our solution. So we like the thing to notice that it's nearly the same thing as the homogeneous solution that you put, but the constants are going to be a little bit offset, and there's an extra x to the fifth term from the non-homogeneous particular solution. So let's consider our initial conditions and get what C1 and C2 are now. And that's why I think you need to wait until you get the entire solution to find C1 and C2, because that particular solution will throw things off. So let's start by finding the derivative of this, I guess. 38 times 5. The answer to that is annoying. That's what it is. 190. I definitely did not use a calculator there. That was all mental math. Minus 6 C1 minus 16 over 3 x to the minus 7 minus 3 C2 minus 22 over 3 x to the minus 4. Okay. We know that y of 1 is negative 4, and y prime of 1 is 34. 39 times 5. Well, 40 times 5 is 200. Take away 5 is 395. Is that right? Calculator, 39 times 5. 195, hell yeah, get wrecked, Spectry. I actually did that one mentally. Y prime of 1 is negative, or y prime, or y of 1 is negative 4, y prime of 1 is 34. If I was the number one answer on Family Feud, survey says. Okay, so this y of 1 equals negative 4 equals 38 over 3 plus, at least 1 is an easy value to work with, relatively. Y prime of 1 is 34. 190 over 3 minus 6 C1 minus 16 over 3 minus 3 C2 minus 22 over 3. Okay, this is two equations, two unknowns, as annoying as it may look, but it is possible to solve it. Can I get Wolfram Alpha to solve this for me? I don't know how to actually input that into Wolfram, to be honest. Maybe these aren't the worst things in the world once we actually group some things. So 38 minus 16 is 22. 22. Oh. Wait, you're telling me these fractions all cancel? I guess they do. Well, that does clean up nicely. Can we hope the same for the y prime? 6 times 16 is 96. 3 times 22 is 66. That's not 190. +96 plus 66 is 162. Ugh, okay. We cannot hope for the same. So, we get 28 over 3 minus 6 C1 minus, oh wait, I messed up a sign. It's 190 plus 6 times 16 over 3 plus 3 times 23. which is even worse. 6 times 16 is 96. 3 times 22 is 66. Plus 190, 352. What a terrible number. 34 times 3 is a job for a calculator. 102. 102 minus 52 is 250. Can multiply this thing through by 3, I guess, just to get rid of that annoying fraction. And, I mean, we can multiply through by -3 as well. 18c1 plus 9c2. Okay. What I'm going to do, take the second equation, put it on top. Take the first equation, multiply it through by 9. Minus 36 equals 9c1 plus 9c2. I'm sorry, this might not be the part of the question that you were stumped on, but I figured you might prefer to see this by hand, so... Oh, I'm sorry, I'm not adding these, I'm subtracting them. If you don't want to see it by hand, though, I can just figure out a way to put it into a calculator. Or use the calculator more. It's 286 equals 9c1. So please tell me that 9 goes into that. 286 over 9. Damn, it doesn't. Does 3 go into 286? I could do the digit trick, but I'm too lazy. It doesn't. Okay. 286 over 9 is c1. So then -4 equals 286 over 9 c1 plus c2. Oops, sorry, no, c1 is just equal to that. c1 goes away. c2 is a negative number. 36 plus 286 is 322. Okay. Oh, the Mario emotes, Anders. I feel like Zach would be all over those. Does 9 go into 322? Dang it. Sure doesn't. 322, no way 3 goes into that. No. Okay, we know what C1 and C2 are. So when Zach says something. Alright, that means y of t is 16 over 3. Oh, wait, where am I? I'm taking this line. 38 over 3x to the 5th. Plus, oh my gosh, more fraction math. We have to take our C1 and subtract out 16 over 3. 286 minus 3 times 16 is 48. 238. X to the -6. There is no t. Wait. I have been known to randomly switch to using t's in differential equations problems. I'm using t x here though. Oh, was I saying t? My brain just always wants to do differential equations with t and not x. So what I've written down, actually what I've written down is even okay. I forgot to multiply in That is 6. Oh my gosh. Okay. That arithmetic is Wolfram Alpha's job, officially. 6 times... So I'm doing that 6 times C1 is 286 over 9. Minus 16 over 3. By the way, why is there a minus sign? Am I taking from the wrong line? I'm taking from y prime. Oh my god, I'm doing it from there. I did it right. Ah! I was just looking at the wrong line. 238 over 9. Is that what I said? Yeah. 238 over 9 x to the negative 6. Now we take C2 and subtract. It's already in negative, so we're going to do 322 plus 66. 322 plus 66. 388. X to the minus 3. Okay. At long last. Oh my gosh, I made that a t. It took a little bit of work, but I'd say this is the solution to the differential equation. So, this virus, I'm not sure if you're still here. I can get back to you on Discord if I don't see you type something here, but... I'm sorry, I don't really know, like, the theory behind why you exactly do some things that you do here, but... Or with, like, variation of parameters when it comes to, like, a non-homogeneous Euler equation like this. But that's at least, like, what you should do, it seems like. Even go one step further and give this thing to Wolfram Alpha. And I don't know how to make it do the initial conditions, but we can at least get the form of the final answer. $176. What did I just hit? Okay, nice. Do they have a different coefficient in front of the x to the 5th? Is that a problem? I assume it's not. Where does that x to the 5th coefficient come from? Oh no, I made a mistake. I dropped that negative sign. That's not a big mistake. Oh no, it messes up. It's a big mistake. Ah, I messed up the C's. Okay. Oh my god. I should have done that first. I should have done that first, dude. It's 6 over 3, which is 2. Oh no. I can't believe I did that. 2, 10. We still get messy fractions for part of this, but... Oh my gosh. Okay, the actual point of the question, or the actual, like, procedure is fine, but we would have to go through and resolve for these constants here. That should be a 2, and that messed up everything down the line. Should wait. If there's a negative, that should be a plus. So that's a plus. So that's a plus. That's a plus. And that's a plus. Actually, well, that goes back to being -4, doesn't it? -3C2. It's that one random minus. Always gets you. Two plus 96/3. We can do that. 102/3. And that goes into 3. Uh, 34. Really? Feels weird. Well, you know, I mean, this is simpler now to the point where I feel like I wouldn't mind solving it by hand again. Gonna multiply the first equation through by 3, I guess. And this time we add. C1 is -22/3. C2 is -4 plus 22/3. -4 plus 22/3. +10/3? Too many numbers? I agree, Anders. Get these numbers out of my math. That's the first thing I thought too, Sereno. Did I check? I saw I was paying, but I didn't look at it. Oh, another Posets one? I'll look at that after. I want to get this cleaned up and send it to Anti-This Virus in Discord since they may have had to dip. Do I have that right? -4 plus 22/3. Yeah. So C1, -22/3. Hey, it's G1. -22/3 plus 16/3. That becomes -2. Okay. And then C2 is 10/3. 10/3 minus 22/3 is -12/3 is -4. Yeah, those are some nice, like, clean coefficients there. Do they match what the anti this virus got? Huh. Yeah, nearly, but then they get offset. Are they? Yeah. Okay, so. Oh, jeez. Wow, look how big this problem turned out to be. Okay, let me get back to the person. Back to you here in case you had to leave. The particular solution, which can be obtained via variation of parameters. Only after that is done should you get the initial conditions, or should you deal with the conditions. I get for a final answer y of x equals 2x to the 5th minus 2x to the minus 6 minus 4x to the minus 3. Okay. So another Poset problem. An example of a chain that is every pair of elements are comparable without the first element such that each element has a successor, but not every element has a successor for another element in the chain. What? Without first element, such that each element has a successor, but not every element is a successor of another element in the chain. If every pair of... What is a successor then? Maybe I don't understand. Is a successor covered by the thing? No, not necessarily. If they're saying immediate. No, okay. Successor is more general. If everything is comparable, do you have to have some maximum thing? Oh, I mean, they were saying immediate. Uh, so the fact that they're talking about an immediate predecessor successor to me implies that a successor it doesn't have to be like covering. It just means that like somewhere down the line. Minestrone soup with rice for dinner. Ooh, that sounds nice. Immediate? Okay. Like, and so we put the word immediate here? I still don't quite know what I haven't figured out what this is asking for, to be honest. And before as well? Okay. So what does the without first element thing mean? Like, don't don't you have to have a first element? Okay, so there's no like global minimum, I guess. Is how I'm like framing that. But okay. An immediate successor is like similar. It basically means like it's being covered. So B is an immediate successor of A if A is greater than B and there is no X such that A is greater than X is greater than B. That's how I'm reading immediate successor. A less than B? Really? Do I need to flip all these inequalities then? Successor is above? Oh, I guess I have the... Okay. Huh, okay. Now I want to switch A and B. But I won't. I don't know. Every pair of elements. So we have to name a set and we have to name a comparison. I'm imagining something like your set is multiples of 2 and you order by powers of 2, but I don't really know why. No, that would have a first element, right? Like 1 would still be the first element? Or rather 2? No? Wait. You get like... No, 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 no. Maybe not. Let me just write out the idea. Set is all numbers 2 to the k with k belonging to, I guess, natural numbers. Depends how you define the powers. If A and B belong to S, A is less than B if and only if I guess even numbers. Yeah. I'm trying to... A equals 2 to the k times some other number m. B is 2 to the l times some other number n. If and k is less than l. That's what I'm trying to say, I guess. I don't know why my brain is saying this. It feels like something that might work. Because there's no like unique first element. Anything with only 1 power of 2 is gonna basically be this. Oh no, but then it's not comparable. Well, no, would we say they're equal? No, maybe they are comparable. I don't know. I guess I streamers can say M and N are odd. K and L are because everything has to have at least 1. Yeah, so that works. Positive. I mean, odd natural numbers, I guess. I don't know if I get what I'm trying to do. Oh, you got a phone call. Okay, well... I'm thinking that the set would be even numbers, and I would compare them by what's the highest power of 2 that is in each even number. This was just me being a little bit extra with being like really exact with how these things are, but So for example, we would say 6 is less than 8 because 6 is 2 times 3, whereas 8 is 2 cubed. And so I think this would do the without first element thing, because that's what I was curious about. So like, can I say if they have the same power of 2 that they're equal? It's like 2 would equal 6, for example. But I don't know if that type of thing is allowed. I guess 20 would be, well, no, they would be equal, I guess. Oh wait, well, this doesn't address the. I don't think I've addressed that bit of the question anyway. Take all even integers with the natural order. Uh, we're not allowed to do equality like that? Okay. That means not comparable? Okay. If it's all even integers with the natural order, I don't think that addresses the last bit of the question, right? If every pair of elements is comparable, though, like I'm trying to figure out what it means for everything to be comparable, but not everything being an immediate successor of another element means. Because I feel like that's a contradiction. I guess we can only have one. Does there have to be exactly one element without? Everything being comparable means you'll get a linear order. Usual order of z, for example. You can also have finite linear orders. You do the hash diagram, you get a vertical line. Okay, that's a neat way of saying it. So if it's just a chain, the hash diagram is just a vertical line. But we need a chain that I think eventually splits off, does it not? So that to meet the no first element condition. Fizzbuzz is saying, I do the integers union the sequence of rationals minus 1 over n for n greater than 0. 0 isn't an immediate successor of any element in my set. Well then, how can we possibly meet the without first element condition then? If it splits, meaning if a split means that it's not a chain. Zero isn't immediate successor. Yeah, it's equal to integers union minus 1 over n natural numbers. Zero isn't an immediate successor. And that's because, oh, so that's because, like we can't point to just one number that's right before zero because they're reading 1/2, 1/4, 1/3, and whatever. Like we can't name just one number that's right before zero. Huh. That's smart. That just, yeah, I guess that just works. Yeah, well done, Fizzbuzz. I definitely don't see the issue with that. Is that what you would say, Anders, or did you have a different idea? Surprisingly about the book Counterexamples and Analysis, but never read it. Apparently it's working for you. The lesson there is to buy more books and not read them. Speaking about something different. Yeah, I was just completely on the wrong direction, I think. So yeah, I can see now how this meets all the conditions, but like how Fizzbuzz thing meets everything. But I was wondering how that's possible to meet everything. But yeah, there's a meet test where it says this way: if zero, they are the same numbers. Not basically it'll be. My answer is very similar, but the same thing with one. Oh, okay. So it's the same sequence, but going towards one. Sequence 1 over n for n and n is a common example used to prove stuff in analysis. Really? I mean, see, now if I was copying Fizzbuzz's homework, I would have just done like minus 1 over n squared or something to make it look different. You know, I think here we can make it. We can do nearly any, like, I guess it's secondly increasing sequence. Also, the point n and n equals one thing. Oh yeah. Well, that is a neat problem then, Anders. Thank you. Okay, I want to finish this last problem from chapter 2 of that physics book, and then maybe wrap things up. Oh yeah, I was getting this stupid thing that I have to solve for D though. That's how I would cite things on a paper. Poingallis? I'm probably saying that wrong. Thank you for the follow. Welcome in. I mean, we can quadratic formula this, I guess. It just solves for root D, does it not? Okay, so minus B is plus 2 root H plus or minus root B squared 4H minus 4AC plus 4D3H. The idea of everything having successor is not necessarily predecessor is a bit... Yeah, that really makes me uncomfortable, Anders. It's like, man, it's like, there obviously should be something there, but you can't actually name it, so I guess it's not there. Poingallis is calling that D equals H. I could see it. Try to solve with something that is not inheriting the usual order because using analysis feels like cheating. Oh god. The way that I'm doing it does feel a little complicated. What is this? 4H plus 12DH over minus 2. You can use the ordinal. Oh, for Anders' problem? Dude, this is a stupid answer. How did I get this? Should D be in terms of H so the balls hit the ground at the same time? Wait. That's why it's stupid. It's now marginally less stupid. Okay. Oh my god. Please don't do that. What are you about to do, Paint? Okay. That boils down, that's root 16, which is 4 root H. Okay, that's not the worst thing in the world. Negative root H plus or minus 2 root H is equal to root D. So if we square each side... Oh, there's even a Kirby one too. This isn't going to have the right units. Oh wait, no, it will if we do the plus case, I think. Because now it's maybe? I don't know. Just FOILed out the old-fashioned way. Not h squared. Oh. Thank you so much for the tier 1 sub, Point Gallus. Holy crap. Welcome in. Minus 2h. Minus 4h? Question mark? I'm going to consult Wolfram Alpha on this because I don't trust my mental mathing this late into a stream. I don't trust my mental mathing in general, but especially not 4.5 hours into a stream. That feels too clean. It's just X. Well, I definitely got a sign wrong. There we go. I see why. It's just... Okay. I had that as -4, which should be +4. So that's just h. What about the negative case? If I flip that to negative, please give me something that doesn't make sense so I can throw it away. That's 9x. Dang it. Go find a different reason to throw one of these away, I guess. Oh my god. No one look at me. These are common terms, aren't they? Okay. Okay, 9h doesn't make sense. So D equals H. Looking intensifies. Square root D can't be negative. Oh, true, that too. Thank you, Pungalis. Okay. Should D be... Okay, so we're saying that just D equals H. Is that right? Survey says... Where am I? Oh, I'm scrolled up. This is number... Oh, no. It's not that 11. It's the different 11. D equals H. Now, they probably did it in a way simpler way. Or not? Wait. Total time it takes the first ball to fall to a height 4h. The first ball to fall a height 4h when it hits the ground. That's a weird way of saying that. It's given by gt squared equals 4h. So that's at that time. The time you divide into the time it takes to fall distance d, which is root 2d over g plus the remaining time it takes to the ground, which we are told is the same as... What? Oh, okay, I guess I see what they're doing with that. So the remaining time it takes to the ground, which you're told is the same as the time it takes. So then... Which is root 2h over g. So the entire time it takes for the first ball to the ground is equal to the time it takes to follow distance d plus the time it takes to follow the rest of the distance. That's a way simpler way of doing it. I would not have thought that on my own, though. Graphically process shown either V versus T plot in figure 2.18a. Area of the large triangle distance 4h, the first ball falls. Sure. Small right triangle is the distance. The right small triangle. Oh god. It's not a small right triangle, it's a right small triangle. Wait. So, yeah, okay. But it's also a right triangle. The right small right triangle is the distance h. The second ball falls. Oh my god. Okay, I'm not gonna understand this right now. My brain is too tired. We got the right answer though. I've done all the chapter 2 questions now. And this will just be a problem for future me to read through and understand. I think I'm gonna wrap things up here though. I can't think anymore. So I'm gonna cut the YouTube stream off here. If you're on YouTube, thank you. I'll be back on Saturday.